Hello students, the question is, consider an expanding sphere of instantaneous radius r whose total mass remains constant. The expansion is such that the instantaneous density ρ remains uniform throughout the volume. The rate of fractional change in density 1 by rho d rho dt is constant. The velocity v of any point on the surface of the expanding sphere is proportional to, the options are given. This question is taken from the chapter Unit Dimension Error and Rate Analysis. Let's do it. Okay, there is a sphere. Suppose this is the sphere whose instantaneous radius is r. This is r, and the mass of the sphere is constant. So remember, m is constant. But since this r, that is the radius of the sphere, is expanding, its density should change. Why? Because density is nothing but mass by volume. Mass is remaining constant, but if r changes or increases with time, then v should also increase, hence rho should decrease. Right, student? Now it is given in the question, see, it is given in the question that the rate of fractional change in density, the rate of fractional change in density. What is the rate of fractional change in density? If you see the fractional change in density, the fractional change in density, fractional change, it is nothing but the change in density divided by original density. This is fractional change in density, and they say rate of fractional change in density. So rate of fractional change should be d rho by rho dt. Right, student? This thing is given as constant. Now we have to find the velocity v of any point on the surface of the sphere. Okay, let's proceed to next slide. This is the sphere again, radius r. Now coming to density, rho is nothing but mass of the sphere divided by volume of the sphere, and we know volume of the sphere is 4 by 3 pi r cube. Right, student? Now for rate calculation, we have to first, let's write it in different way, 3m by 4 pi r cube. Okay, first we have to take log on both sides. This is the procedure of rate calculation, taking log on both sides. We get log rho equals to log 3m by 4 pi r cube. Now from the operation of log, we know I can write this right hand side as log 3 by 4 pi plus log m minus log r cube. Right, student? You all know. Now see, look at these two terms. 3 by 4 pi is a constant. M, according to the problem, m is also constant. Now taking derivative on both sides, we get log rho, derivative gives you d rho by rho. Since this thing is constant, so its derivative is 0. M is constant, so log m is also constant, so its derivative is also 0. Now for this part, I can write like this, minus 3 dr divided by r. Right, student? Therefore the fractional change in density is nothing but 3 times of the fractional change in radius with a negative sign. The negative sign indicates that rho is decreasing with increase in r. Okay, now what is the velocity of any point? See, velocity v of any point on the surface of the sphere. Now velocity at this point, it is nothing but dr dt. Why? Because this point is increasing, or the distance from the center of this point is increasing at the same rate at which radius is increasing, right? Therefore I can say, look at this, I can write this equation like this: d rho by rho dt equals to minus 3 dr by r dt. See, I take dt on both sides in denominator. Therefore, according to the problem, now see, look at this. According to the problem, this thing is given as constant, d rho by rho dt, right? Therefore, I can say this right hand side should also be constant. Proceed to next slide. Sorry. Therefore, this right hand side is also constant. So minus 3 dr by r dt is also constant. Now dr dt, as I mentioned earlier, is nothing but the velocity. So minus 3v divided by r equals to constant. Therefore I can say v is proportional to radius. Therefore the correct option is option A, v is directly proportional to r. Thank you for watching this video. If you like, please subscribe my channel, Phi Solver.